Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is automatic transmission operation and testing. So we're going to really focus on the diagnostic side of things, like how the sensors and things like that work. We're not really going to talk about the mechanical aspects of it. Maybe a little bit towards the end, we're going to talk about a couple different transmission types that are out there. But mainly it's going to focus on, the diagnostic side of things, how these things work, how the systems work, how they're controlled. So let's get into it. So first off, let's talk about how do I even select a gear on these things. And the most traditional way, as far as automatic transmissions, and they are still used to this day, cable gear shift. So cable moves an inhibitor switch. So if we see right here, this is the switch itself, and then the cable would mount right there. This rod actually goes into the transmission to change the gears themselves within the valve body. But this switch tells the computer what gear you want to be in. So it's a simple rotary type switch. And what you're going to do is you're going to test the continuity between the pins. Now, proper alignment, however, is key. So in this case, this one's off of Subaru, and it kind of pivots in the middle. So you see these oblong holes for the screws, because it does need to be adjusted from time to time, I guess. But there is a hole that you can put a cotter pin, or not a cotter pin, a punch through, and line it up with the case of the transmission to make sure it's in the right spot. And other vehicles have similar ways to do it. The important thing is it needs to be correct. And if it moves at all, like maybe it gets loose or something and it vibrates and it rotates, then the computer might think you're not in park or neutral when you're trying to start the vehicle, and then you might get a no start. And you look at a bunch of things and find out that, hey, the no start was actually, this was just misaligned. I realigned it and it was fine. So just be aware that when you're testing for things like that, check the data. You can tell that by the data. If the TCM does not report that it's in park, even though you got it in park, then something's not quite aligned there correctly, right? And then some modern switches are internal instead of external. So that brings up a whole other can of worms, I guess, if you need to adjust those. So definitely some good advice for that. Now, if we look at the switch itself, we see we have three sets of switches, I guess, three sets of contacts. This one has park and neutral, and those go to the starting charging system. So that goes back to what I was saying. If for some reason it's not making contact there, maybe it's halfway in between or it's in reverse and it's not supposed to be, then it won't make the signal go to the starting and charging system, will not allow start. This one's for the reverse circuit, because that goes to the serial light system. So when it hits reverse, it sends a signal out, closes the circuit, and sends a signal out to turn on the lights. And then down here, the actual what indicate to the computer what gear we're in. So in this case, this is an older model, so it has direct wires to each individual pin on the TCM there. So some of them do it electronically now instead of having just the direct connection from park or reverse neutral drive. Also with these, and not necessarily just these, but there's also sport shift that you can see in a vehicle. So you pull the gate a little to the left, and then you just kind of go forward and backward to manually shift your automatic transmission. Can be had with or without cable. It's simple switches for the plus and minus. So it's a switch to know it's in the gate, and then a micro switch to go forward, a micro switch to go backwards, and then it just sends it. Sends the signal along. So you'd want to test for continuity between the pins. Alternatively, steering wheel paddles and switches can be used. Now, usually when it comes to the steering wheel, probably not so much micro switches anymore. Well, I guess they got probably micro switches in them, but they're not sending voltage. They're usually sending like a LIN signal over LIN bus. So oftentimes, like most of the things on the steering wheel nowadays, send a signal over LIN bus to whatever module needs it. So this is the sport shift switch. So that's when you put it in the gate, and then up and down, right? So you got plus, minus, and the sport shift switch there. And those send the signals out to the TCM, so the TCM knows it's time to shift up, it's time to shift down. Then we get into the wonderful world of knobs. So this started, I believe it started in Chrysler's. It's definitely very common in Chrysler, FCA, Stellantis, whatever you want to call them. Other vehicles do use them as well, but I thought it was a really interesting choice to, have a big knob next to a bunch of other big knobs. And if I'm trying to pay attention to driving, not looking at where the knob is, and I'm just kind of trying to hold my hand over, maybe a mistake might happen. Actually, come to think of it, I think there was some like movie or TV star that passed away because his Jeep crushed him at the end of his driveway because he thought it was in park and it wasn't. So there you go. And it did have a knob shifter as far as I recall. Anyways, it works as a digital rotary encoder, so it's just all digital. Sends it over the network. You're going to use a scan tool to diagnose it. You might be able to use scope as well, because it does go over CAN. So in this case, we have the data bus for the shifter and CAN. Then there's other CAN bus associated with it as well. But from the shifter to the transmission control module, it's all CAN. So you could check for a CAN bus signal there too, I guess, when you're changing gears. Or you can check to see if the data changes as well in the transmission control module. We've gone back to buttons. Way back in the day, there used to be button shifts on the console or on the dashboard, and now they're back in GM and other vehicles. All communication, once again, is over a network. This is basically just a module, and then use the scan tool to diag. I could actually manually shift up and down here too, which is kind of an interesting choice. But you definitely use your scan tool checking for data, because this is going to be, once again, digital data, network data going over the lines there. So in this case, this is off a GMC Acadia. Gear shift control modules right there, and then we have multiple data lines coming off of it. And there's a logic panel in there. And it sends the signal digitally, like I said. And then more recently, even, we have stock gear shifts. So this is another thing. The first time I ever saw it was in a GM. I'm sure there's other manufacturers that are doing this too. I had like a brand new Acadia as a rental a few months ago, and I'm like, oh, where's the? Oh, there's the shifter. It's not my wipers anymore. It's my shifter. And how in the world do I get this thing out of park? So luckily they label it, but it is not intuitive at all. If you're in multiple different vehicles, like in rental cars and stuff like that all the time, it's not that intuitive. I'm sure you get used to it after a while. Once again, this is all digital, so it comms over the network, and use a scan tool to diag, possibly a scope, if you're trying to read the signals. Now, another interesting thing with this, if you look at the wiring diagram, is here is my gear shift control module, which is in the steering column, the right side stock. Looks like it does have actual micro switches in there, probably. It does have where it makes connections, but it all connects into a logic board, and then the logic board makes the decision on what to do. Now, also interesting though, is it is provided a 2.5 volt reference and a 1.5 volt reference. So if I were to just look at this and I didn't realize, I didn't look at the wiring diagram maybe, and I was looking for a 5 volt reference somewhere, and I'm only finding 2.5 volts. I'll think, oh, well, I got a voltage loss somewhere. Well, guess what? It only runs on a 2.5 volt reference there and a 1.5 volt reference there. So luckily it's spelled out in the wiring diagram, right? But that's certainly an interesting choice there as well. I mean, I'm sure it doesn't need that much voltage to process what it needs to do, but everyone else uses 5 volts. I don't know why they couldn't just use 5 volts across the board. But anyways, that's a thing that exists, and you may have to diagnose it sometimes. So maybe keep that in mind. All right, let's go to the sensors that are going to help the computer understand what's going on in that transmission. So we have a temp sensor for the fluid temperature. So some are negative coefficient thermistors, some are positive coefficient thermistors. In the case of a negative coefficient, as the temp increases, the voltage decreases. Test for voltage and resistance, and sometimes it's part of the valve body. And due to it being part of the valve body, it might be difficult to access. Some of them, they're kind of like on a harness right there, and it's easy to get to when you drop the pan. Other ones, they're maybe up on top or just in a not as easily accessible place. So in this case, this is on a 2001 Chevy, so a 4L60. Transmission fluid temperature sensor is a 2-wire thermistor. As the transmission temp increases, thermistor resistance and signal voltage decrease. Cold transmission, voltage is sent through a high resistance circuit. Warm transmission, voltage is sent through a low resistance circuit. This dual circuit improves accuracy over all temp ranges. PCM uses the transmission fluid temperature signal to determine shift patterns, engage or disengage torque converter, and determine hot mode operation. So it's also be able to find this temperature to resistance to voltage chart. So if it's say 104 degrees Fahrenheit, 40 degrees Celsius, that'd be 1313 minimum, 1459 nominal, and 1605 maximum, which gives us an output voltage of roughly 1.10 volts is what we should see there. So you can see how it varies a little bit. And right here is where it looks like it switches over too, because it goes from 3.45 down to 1, and then it goes 3.25 down to 0. So there's a little bit of a switch over there in the middle too. So we go from the high resistance to low resistance circuit, like they talked about. Next is a speed sensor. Generally speaking, they're going to be a Hall effect sensor, 3-wire. Reads input and or output shaft speed or multiple shaft speeds. It could be multiple things. But you're generally going to have 2. You're going to have at least an input or an output and or an output. You're going to test it for voltage or resistance. Sometimes it's part of the valve body, and due to, once again, it being part of the valve body in that case, it can be difficult to access. Sometimes they're right on the outside of the vehicle, and they just bolt in like a crank sensor or a cam sensor. That makes it a lot easier. So this would obviously be an external one. Looks like it's a Mitsubishi according to that logo right there, but it's just a Hall effect sensor like a cam or crank sensor. In this case, is on an 09 Subaru, and that is the 5-speed automatic that they had for a while. So turbine speed sensor 1 measures trans input shaft speed and torque converter speed. Turbine speed sensor 2 measures transmission speed. So this is one where they actually had some issues with these, at least the early ones, because the stack would move and shift inside the transmission, and then it could throw a code for a speed sensor because the plate that it reads might go out of where it needs to be, right? So I think it was probably just the early ones, but I do remember we had to deal with that in the shop where they were shifting. And then here we go. Let's just doing a DC voltage test, right? So it should be more than 1 volt AC, vehicle speed at least 12 miles an hour. So this actually does volts AC in this case. Now, remember how I said sometimes they could be difficult to access? Well, here's one on a GM, and you can see there's the connector there, which goes to kind of off the side there. There's the TCM. And then the 2 speed sensors are actually right above the valve body. So you would have to drop the valve body in order to access that. And probably, unless there's an alternate location you could test it, you probably have to test it outside of the vehicle because you can't get to it to test it. All right. Next, we'll get to the solenoids. There's 2 different types of solenoids you're going to find in an automatic transmission, and they're usually going to be for moving fluid around within the valve body, shift solenoids and such. So we have on-off solenoids, which are either on or off, open or closed. Computer controls the ground side or the power side, depending on how it's wired. It's an open-close function. Like I said, it's either on or off. Sometimes it's part of the valve body. Generally speaking, they're going to be in the valve body at any rate. They could be from underneath. There's a couple of vehicles I've seen where it's like all in a row in the back of the valve body. That makes it fairly easy to get to. I know like on Subarus, there's like a bunch of them around the bottom of the valve body. So it's just one bolt and a plug and it comes right out. Sometimes they're on top. Just depends on the manufacturer. So due to that, could be difficult to access. So here's an example on a Subaru. So we got a bunch of shift solenoids, low clutch timing solenoid, 2/4 brake timing solenoid, all-wheel drive solenoid, etc. Everything kind of goes through that one connector, and then it gives you a little shift pattern here. So to be in first gear, both solenoids are on, and then so on and so forth. And in this case, it's going to be at the main connector, so it's easy enough to get to. Shift solenoids 1 and 2 are on-off type solenoids. And then some of the other solenoids are going to be a pulse width modulated solenoid. So it's modulated on or off. Computer controls power or ground side, depending. Open and closes by a percentage. So say I want to close 80, open or closed 80% of the time, or what have you. Just opens for a fraction of time. Once again, sometimes part of a valve body, and if it is, it can be difficult to access. Sometimes you can only get it's not replaceable. Right. So the torque converter clutch, in this case, integral part of the solenoid body, and being so, it's not available as a separate unit. So in this case, it is part of the valve body. So you have to order a valve body if this fails. Torque converter clutch solenoid is both power side and ground side controlled by the PCM or TCM on some vehicles. Controls common solenoid power used by all solenoids in order to cut power in case of a circuit fault. Solenoid duty cycle is controlled on the ground side to allow for smooth torque converter clutch actuation. And this is on a Ford Explorer. And then in this case, we're looking at duty cycles. So you're going to observe the percentage of duty cycles. So in this case, it looks like we got up to about 75% or so. PCM may command torque converter on in 2nd through 6th gears. Converter is locked when at least 65%. So in this case, we got to about 75, almost 80%. So that is locked at that point. So it was not locked down here. Then it comes up to here, and then it's locked. And then goes from there. And then we have some tech notes here on, this transmission uses 2 on-off type shift solenoids and 6 pulse width modulated type solenoids for pressure control. And this is on a 2011 Camaro. So normally high, normally low. And then, in whatever combination they need to get through all these different gear combinations. And of course, the more gears we have in a transmission, the more solenoids we'll need to make it work. We could also do pressure testing. So if we use a pressure gauge, or you could even use a pressure transducer on this. In this case, 500 PSI they want. And then you can check your actual pressure based on your command pressure change. And then we get to adaptives. So adaptives are used on multiple manufacturers. I think probably pretty much everybody nowadays uses some sort of adaptation. As you drive, it learns how you drive. So to equalize tolerances and wear, an automatic adaptation takes place for shift time, clutch filling pressure, torque converter lockup control. Adaptation data may be stored permanently and to some extent can be diagnosed. And then there's driving style adaptation. Shift point is modified in steps based on the information from the inputs. The control module looks at these different inputs, and based on how aggressive the driver is, the TCM moves up the shift so the present gear is held a little longer before the next upshift. So if you drive like a little old lady, it's going to shift differently than if you drive like a race car driver, right? So it adapts over time. And when you replace things in the transmission, you do need to, usually you're going to use the scan tool to initiate some sort of a learning mode, adaptation mode. So in this case, once again, a GM service fast learn adapts. There's a bunch of every manufacturer calls it something different. But it says the procedure must be performed when one of the following repairs have been made to the vehicle. Failure to perform the procedure after one of the following repairs may result in poor transmission performance as well as transmission codes being set. So a transmission internal service or overhaul, valve body repair or replacement, control solenoid valve assembly replacement, TCM software calibration update, any service in response to a shift quality concern. So it needs to get done anytime any of that happens. So that sounds like pretty much any transmission work you're going to run into. So that's the controls. And like I said, we're going to be focusing mainly on the electronics side of things, the things we would use the scan tool to diagnose. However, there are a few unique transmission types out there that have their own unique challenges as well when it comes to diagnosing and such. So this is your standard hydraulic automatic transmissions, been around forever. There's multiple variations on a theme here, but you get your clutch packs and you get your planetary gear sets and things like that. Like I said, I'm not really getting into the teardown type thing with this. We got some pistons. I've had plenty of transmissions apart that rebuild in my life. That's what we would usually do, is rebuild them in the case, because there are some fairly common problems, like going from reverse to drive and it takes like 2 seconds to engage drive and it jerks. Well, that's automatically a low reverse clutch pack. The clutch pack's worn. You can just buy it as an assembly, pull the old one out, put the new one in. Sometimes you had to rebuild them too, but generally speaking, we just ordered as an assembly. But nowadays, I'm sure most places, unless they're a dedicated transmission shop, probably just put a new unit in, right? Get a reman unit or something like that. But if you've ever had an automatic transmission apart, you know there's a lot of parts and you know there's a lot of pieces in there, and there's tolerances, so you got to get everything right. But that is your standard hydraulic automatic transmission. That's, like I said, it's been around forever. There are a couple different transmissions that are out there now that are a little unique. So in this one's the Volkswagen and Audi DSG, so that's a dual shift gearbox. And this is basically a hydraulically actuated manual transmission with 2 clutches. That's what it is. And we can see actually it's got a cable shifter. So look at that. So the home of this, the heart of this, is going to be dual input shafts. So they ride, the outer one rides on the inner one. You see that the outer side has a larger spline than the inner one, and that is to go into the 2 different clutches. Now you see that half the gears or so go into one and half the gears go in the other. That's because if it's first gear's on one shaft, second gear's on the other shaft, third gear, and so on. So it kind of alternates back and forth in order to, be able to shift using the automated clutch. And the automated clutch that they use in Volkswagen and Audi, it's actually like a friction clutch that you would see on a standard transmission or manual transmission. So it has two clutches. You see that one has a larger spline and one has a smaller spline. So the larger spline goes on the outer shaft, smaller spline goes on the inner shaft, and then we have 2 clutch forks here that kind of operate within each other. And then these are actuated by hydraulic pistons, right? So hydraulic actuators, they call it the mechatronics. So that's one way of doing it, and that's how, like I said, Volkswagen Audi decided to do it on their dual shift gearbox. BMW also has a dual clutch transmission, which is essentially a manual transmission, but instead of using clutches, it actually uses dual clutch packs like on an automatic transmission. So it's hydraulically actuated just by compressing the clutch packs instead of having the forks and the friction material and the pressure plates and all that other stuff that Volkswagen did. Seems to me this is probably, it's like less moving parts, so it should be simpler, I would imagine. And it's probably just a clutch pack that you would just replace. I don't know. I've never had to replace one myself. You could probably rebuild it. They probably sell you a whole thing, or you just replace the whole transmission. I don't know. But it does look very much like those clutch packs we saw in the automatic transmission, the hydraulic actuated transmission, because they are. It's the same idea. And this normally would be on the shaft. This has got two input shafts as well for the 2 clutches. So the clutches kind of overrun each other. And it's got the mechatronic unit over here, which helps with the pressures and stuff like that. And there are some things that need to be done scan tool wise on that too, because of the oils and stuff like that. Next one's the CVT. Many manufacturers have gone to a CVT. Many manufacturers have not gone to a CVT. Some manufacturers, instead of making a continuously variable transmission, which is what CVT stands for, they decided they're just going to keep adding gears. We got 10-speed gearboxes out there now, 11-speed gearboxes out there now, automatics. So just all in the name of fuel economy, really. But the CVT, this one's off of Subaru, so it's a little less compact than some other models you might find out there. But, I mean, it started with, they've been around forever, but, probably the biggest mass market one was the, like the Murano. That was probably one of the more famous ones, I guess, because they used to break all the time spectacularly. So much so that Subaru bought a bunch of them to tear them down and find out where the weak points are and engineer that out when they made theirs. But anyways, we can see we got 2 pulleys, and they're kind of variable pulleys, and this is a metal belt that goes in between the 2 pulleys. And by changing the size of the pulley, you're changing the speed of the output shaft. So the input shaft's probably going to be the same speed. That was the wild thing. The very first time I drove one of these was, you're driving down the road and it's accelerating, but the RPM's stuck at 3,000 RPM. It's not going any higher, but the speed sure is. So it's just continuously just changing and varying those to increase the output speed. No actual gear changes. Of course, there's gears in there, mesh gears, but There's gear changes. Now, so much so that nowadays many manufacturers have programmed in actual shift points. So it feels like the car's shifting even though it's not. So I'd imagine it probably just gives it a quick jolt or something to make it feel like a shift. I'm not 100% sure how they make it feel that way, but because I know my mom's got a 2017 Crosstrek and it feels like it shifts even though it's got a CVT in it. So I think it's just because end users were a little disconcerted with, or maybe they were going way too fast, because I could see that happening too. I can accelerate up to 80 without really noticing, and like, oh boy, I'm speeding. Okay, let's slow it down a little bit. So um, I would imagine it was end user feedback that caused that to happen. It's kind of interesting. So like I said, metal belt, two pulleys that change size so they can, one spins faster than the other. Usually, I believe most manufacturers say if anything goes wrong with these, it just gets a transmission anyways. I just thought it was kind of funny when we got trained on these. For the first year, it was like 2010 model year. They actually had us go in and tear them down and rebuild them. And then after that, they said, "Well, you're never going to do that because if it's so much as leaks to drop, we want it back, and we're going to send you a new one." So don't know why they had us ever tear them down, because I think even still to this day, 15 years later, that they're just putting remands in if they need it, anything to do with the transmission. Don't take it apart. It's permanent fluid. Don't need to do anything with it. Just don't touch it. Just let it go, I guess. And you see it's all electronically controlled, right? So we got clutches in there, brakes in there, but it's all like oil pressure switches, and the TCM just controls everything. So really no tear down going to happen with one of those. Maybe you might, maybe if you like doing it, I don't know, I guess you could, but more than likely, it's probably going to get a transmission. All right, let's go live on the tool and take a look at a few examples of what I just spoke about. So first one's going to be this 2022 Volkswagen Taos. And that has the dual shift gearbox. So I'm just going to load in there, go into number 2 transmission. Gonna tell me I'm in sim mode. I got to pick the right one, and that is this one. And you can see, oh, by the way, 2022 Volkswagen. So that means we have SFD with the, which is the secure functions. Secure Functions Diagnostics, I believe is what that stands for. It's German, they mix up the words. But some systems may require access to manufacturer secure diagnostic requests. So we might be able to see that, I think, if we go into functional tests. Yeah. I can, in the simulator, I can simulate any of the modes. So we'll just say it's locked and go in. Now with Snap-on tools, with Volkswagen and Audi vehicles, in order to access these secured functions, all you need to do is set up a free profile access code in your Snap-on profile. So it's any 4 digits. And if it needs access, it's going to prompt you to enter those 4 digits here. So I'm going to enter the wrong ones just so you can see what happens. And okay. Oh, sorry. Invalid code, 4 attempts remaining. So you get 5 total attempts to get in, and it just locks you out. So I'm going to put in the right one now. Okay. And now it'll allow me to do the functional test. So Volkswagen Audi is a little bit different than what you might notice with like Stellantis, where they lock the whole vehicle out, and Nissan, where they lock the whole vehicle out. Volkswagen and Audi, it is down to the functional test level. So you won't get prompted until you get to a test that's secured, which is good. Saves you time and hassle. So if we go into special functions, see we have things like check oil level, adapt installation info, and basic setting of transmission. So like installation info, following steps will be performed. Establish basic setting for CAN installation information. And it's only going to let me go so far, but this needs to be done after the following activities. Software update, after the replacement of the control module, after the replacement of the selector lever even, after work on the steering wheel paddles, and after another control module is replaced, for example, engine ABS or gateway. So this needs to get done in a fair number of circumstances. I'm just going to go in there, and it's going to probably fail. Oh, I know this is the one that runs forever and never stops. So it's just going to go through and do the routine on a real live vehicle, not a simulator. It would go through and say, all right, it's complete. In this case, I need to cancel. Check oil level. It's a bit of a challenge to check the transmission fluid on these, I guess. So selector level on P, vehicle on flat surface, lower engine insulation cover removed, and transmission fluid test temperature between those. And when I hit continue, it's going to see it's 771 degrees, so it's not going to let it happen. Basic setting of transmission is going to be similar. When I do a software adaptation, replace the mechatronics, replace the clutch, or event memory of this P175 code. And that needs to get done. If the entire transmission is replaced, you don't have to do this because it's going to have basic settings anyways. Engage P, start engine and let it idle, and it's going to say it's too hot. So, but let's see if it just lets me exit. There we go. Test parameters are not correct. Now, this brings me to another point. We get phone calls a lot at the tech support center and say, hey, this test doesn't work. Why is it not working? It's broken, et cetera, et cetera. Well, the manufacturer has sometimes, oftentimes actually, there's certain set parameters that need to be met in order to do this function. So we will not let the function happen unless it's, matches what the computer wants. So most times we will try and have that verbalized on the screen, or like it said there, it need to be between 35 and 45 Celsius or whatever. So we will try as best we can to verbalize on the screen. If for some reason we don't, then we find it and then we try and fix that. So the vast majority of the time, you should find help when it comes to that type of thing. If you don't find it in the tool, always look in your repair information, and that should give you the information you need as to what it needs in order to do its tests. Next one, we'll do a big old Ford diesel, 350. And this one kind of unique with the transmission. So there's a function in here we added about 8 years ago in the functional test, special functions. That is the transmission characterization and solenoid identification. So let's think about, I'm trying to diagnose this transmission. Maybe I've figured out that it's one of the solenoids and I know what solenoid it is. I just don't know what solenoid's in the transmission because I haven't totally disassembled it yet. Maybe I've been able to test it from the outside or something like that. And I want to order it, but I want to make this vehicle be able to move because I got to wait for the part to come in and all that. So this will help by telling us both how the transmission is set up. So it's used to read the transmission strategy and identification from the module. Refer to the vehicle workshop manual for further system details. So it's going to confirm that this is what's in there. It's a 10-speed. I'll say yes. And then it's going to give you the numbers that you need for something. Transmission identification and strategy should match the service tag on the transmission. If the tag's missing, damage, or if the strategy identification does not match the tag, it may be necessary to remove the main control cover and obtain the identification and strategy information from the solenoid body, but it allows you to read that without it. And then as far as the individual solenoids, use to obtain the transmission solenoid band information for ordering individual replacement solenoids. So every solenoid is going to be a little bit different. So in this case, we're going to go with this and provide transmission solenoid band information for individual solenoid replacement. It's going to give us the strategy, the body, and then it'll tell you what solenoid is what, and then what band number and the range. And they would, of course, all be different. In this case, it's a simulator, so all they're going to be the same. But it would give you, hey, I need this particular shift solenoid. You call the dealership and say, hey, I need this solenoid with band number this, range number this, and then they'll send you the right one to replace it. So that could be helpful in those types of circumstances. Also in here, I believe we may have, let's see. Yes, we have guided component tests as well on this transmission. Not the 6-speed though. I guess that's the only one we got. It's a 6-speed. So TCM, transmission information, transmission connector, turbine speed sensor, range sensor, shift solenoids, lockup solenoid, output speed sensor, line pressure, all these different things that we can test. So let's say the lockup solenoid, it's going to tell you to test it at the transmission or the TCM. 3-port directly proportional VFS type located in the trans valve body. TCM supplies 12 volts of torque for a clutch solenoid. TCM electronically controlled driver commands ground on time to modulate the pressure. On time. Weird way to put, quotes around that. All right, and then lastly, we have the 2016 BMW 228i, which is going to have the dual clutch, transmission, the dual automatic clutch packs. And in this case, we have oil balancing. We're just going to be able to tell me some stuff. Let's see. Oil level in the automatic gearbox can only be adjusted when the following conditions are met. And then it's going to ask you, why does it need to be adjusted? So it has faults stored in the transmission control for oil level check, or the mechatronics or converters have been replaced, or parts have been replaced. No mechatronics, no converter, but anything else that got replaced. So whatever situation it is, let's say we did something on the mechatronics. Raise vehicle so the wheels turn freely, and apply the parking brake. Move the oil filler plug according to the instructions. With the engine turned off, fill the gearbox up to the lower edge of the fill plug hole. Start the engine. Immediately fill transmission with oil again until it overflows. Refit the oil filler plug according to instructions. And then confirm you deactivated the stability control. And it's going to give you a bunch of things. Position P, hold the engine speed to 2,000 RPM for 30 seconds, filling the converter. It's just going to go through a bunch of different stuff. And this is probably where it's going to stop because it's 723 degrees. So that's interesting. So that's oil balancing. These get done then. We have an oil adjustment, a fluid adjustment, gearbox adaptation, and teach in the clutch slipping point. So there's multiple different functions available for that on that transmission that might need to get done. And with that, I am done. So that is automatic transmissions diagnosis. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.